interpretations of derivatives. We're looking at one of the sections called Analyzing Related Rates Problems Expressions. Really, all we need to do here is just understand the sort of information that's being provided. Consider the following problem. The height h of t of a rectangle is increasing at a rate of 11 centimeters per day, and the width w of t of the rectangle is decreasing at the rate of 9 centimeters per day. It's kind of like the rectangle is stretching but shrinking at the same time, if you imagine the length is up and down and width is side to side. At a certain instant t sub 0, the height is 3 centimeters and the width is 8 centimeters. So we are asked the question, what is the rate of change of the area a of t of the rectangle at that instant? This is a great problem just to evaluate, work all the way through. Sketch it, find the formula, which is area length times width, and then evaluate it, and then take the derivative, and then evaluate the derivative. There's some kind of mix and match of that last one along the way. But get an answer, get a determinant, an actual answer, and then last of all, put it into context. But really all this question is asking us to do is not solve the problem so much as it is to know the units that we're discussing throughout the problem. Since, I'll go at the first row, w of t sub 0 is the width at that specific instance. Width is measured in centimeters. I have to make sure that I mark centimeters for that section. dA dt, this is row 2. The differential of area divided by the differential of time. I don't think the divided is the proper way to say it, but the point being is that dA dt is the change in area with respect to the change in time. With respect is a better word than divide in a calc problem. Since area is a centimeter squared problem and t sub 0, is measured in days, we are looking at centimeters squared per day. Height, h of t, specifically is the height, and it's measured in centimeters. So I'm going to choose those two values, centimeters, centimeters squared per day, and centimeters as my units of measurement. See if I'm right. Knew it. Hey, I'm going to do a part 2. Why don't you watch it? See you in a little bit.